Good morning, everyone. Today we're going to learn the quotient rule, which is in the same vein as product rule and chain rule. This is our last rule in this section. Okay, and in some ways this is kind of a bonus rule because yesterday, with product and chain, we were able to differentiate things that had a numerator and denominator. So you don't have to use this rule. However, it's a little bit more efficient than using product and chain to differentiate rational functions. Okay, so here's the setup. So I have some rational function. Okay, we'll call it h of x, which is made up of f of x and g of x, right? F of x is my numerator, g of x is my denominator. Okay, and like the previous days, we have a couple conditions. Okay, f and g have to be differentiable, and a new one, right? My denominator shouldn't be 0. So this won't really work when g of x is equal to 0. So we have that restriction as well, that g of x is not equal to 0. Okay, but that would mean it would probably produce an asymptote or something anyway. So it wouldn't be differentiable there anyway. Okay, so if those are good to go, right, we know how to take the derivatives of both the numerator and the denominator. Then the expression for the derivative is this. Okay, h prime of x is equal to the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so it looks a little bit like product rule, okay, except it's got the minus sign in there, not the plus. Okay, and of course we have this new part with the denominator. We're squaring our denominator. Okay. So we're just going to run through a couple examples, and that'll be pretty much it. So here's the first one. Here we're going to differentiate 3x squared plus 1 over 2 minus x squared. All right. So again, it's just following the pattern here. So h prime of x equals, okay, I start with my numerator. So the derivative of the numerator is 6x times the denominator, okay, minus the numerator times the derivative of the denominator, which is negative 2x, all over the denominator squared. All right. Now, the expression on the top, okay, is relatively straightforward, so we're just going to expand that out and tidy it up. So we've got 12x minus 6x cubed. Okay, now be a little careful here. Right? I've got that negative in front of that entire expression. Okay, so for example, when I multiply something through like 3x squared minus 2x, that gives me negative 6x, but I was subtracting it. So I'm really going to have plus 6x cubed. Okay, and then for the last pair, right, 1 times negative 2x is negative 2x, but I was really subtracting it, so that's plus 2x. Because I made my fraction bar a little bit too big there. And the denominator, yeah, all I can really do there, well, that's the power 4 now. And in this case, my numerator cleans up quite nicely. My cube terms cancel, and I have 14x over 2 minus x all to the 4, and that's done. All right, one more example. Okay, and this is a little bit like the one we did yesterday. We've also thrown a square root, our most fun thing to deal with when we have derivatives. Okay. So yesterday, when we did these, we rewrote the expression and got the denominator out by using negative exponents. Okay, we're not going to do that, but I am going to remind myself that the denominator, I have 2x, and this is x plus 1 to the half on the bottom, because that's going to help me a little bit when I set this up. So y prime equals, same procedure. So we start with the numerator. Okay, it's 2 times the denominator, x plus 1 to the half, minus the numerator, 2x, times the derivative of the denominator. Okay, so what's the derivative of x plus 1 to the half? Well, this is where chain rule comes in again. So 1/2 x plus 1 to the negative 1/2. The derivative of the inside is 1. Okay, and that's all over the denominator squared. So x plus 1 to the half. Okay, y prime equals some tidy up steps here. Just a very small one. Right over here, I can multiply the half and the 2x. So we'll tidy that part up for a second. So I have 2 x plus 1 to the half minus 2 times the half is 1. So x times x plus 1 to the negative half. All over. Oops, I did miss something down there. This whole thing is squared. Okay, in the denominator, half squared, so half times 2 is 1. So I just have an x plus 1 at the moment down there. Now, like yesterday, I've got 2x plus 1 terms in the numerator. So that means I'm going to want to factor that out. Okay, so my lowest power is negative 1/2. So I have x plus 1 to the negative 1/2 times, okay, what do I have left? From the first term, when I factor that out, again, right, it's x to the 1/2 divided by x to the negative half. So I'm going to have 2 times x plus 1. Okay, and from the second term, I'm factoring out the x plus 1 to the half. So I'm just going to have negative x. Subtract x left. It's all over x plus 1. Okay, so I can push my negative exponent into the denominator now. So I have x plus 1 to the half times x plus 1. And inside the brackets, I got 2 times x minus x. Isn't that interesting? I get another x plus 1. No, not plus 1, plus 2. Okay, I was worried for a second there. Okay, so only thing left to do now is I can clean up the denominator a bit more. Okay, this is power 1, so when I add those together, I'm going to get x plus 1 to the 3/2, okay, which means finally I can write that expression as y prime equals x plus 2 over the root of x plus 1 cubed. And there is the final form of my derivative. Okay? And again, hopefully I haven't made any weird errors there, as I sometimes do. If I did, just let me know tomorrow and we'll clear those up. Okay, but that's the process, right? Just follow the pattern, fill things in, and that will allow you to take your derivative using quotient rule. All right, so that's it for this lesson. Okay, there is some practice work that would allow you to practice quotient rule. Okay, or of course you've got that assignment. There should be extra copies on my desk if you don't have one, or it's on the website, whatever suits your time the best here. All right, so thanks for watching, and I will see you tomorrow.